Hey, good morning, everybody. Thank you. Now I know I can hear you. You guys look pretty comfortable. I feel like I'm addressing in the Phantom Menace in the beginning of the Senate, that real exciting scene. So I wish I could present from one of those seats. Looks very comfortable. So today I'm going to be talking about TDD and SQL. So when I tell people what I'm going to be talking about, I say, well, I'm going to talk about TDD and I'm going to talk about SQL. And they kind of step back and go, really? That's what you're talking about? So two things that I personally enjoy, and the reason I wanted to give this talk is because I like TDD. I think it's important. I think it's valuable and useful. I do like writing SQL as well, and kind of SQL doesn't often get tested, and I'll talk about that throughout this presentation. Also, I'm going to be talking about SQL Server. So when I say MySQL DB, it means the SQL DB that belongs to me, not the MySQL database. So fair warning, in case you're expecting a MySQL talk. So my name's Jeff McKenzie. I'm a principal consultant at Cardinal Solutions. Cardinal is a professional IT services firm. We have approximately 500 full-time consultants across the East region. We're expanding all the time. We have about 8 branches, including one in downtown Columbus in the Arena District. Cardinal has been a sponsor of Stir Trek for a number of years. We're a sponsor again this year. We're hiring in all areas. We do work in app dev, do a lot of cloud work. We do IoT, data, AR and VR work, as well as DevOps, pretty much across the board. So we're hiring. We're looking. If you're looking for an opportunity, feel free to contact me afterward or stop by our booth here at Stir Trek. We also have the Slack channel open. So we are 2018 Gauntlet, I believe. So if you have questions, if you're in one of the other theaters, if you have a question you want to post to Slack, if there's time at the end, then we can try to address those. So today I'm going to talk a little bit about TDD, test-driven development. How many of you have heard about TDD or kind of know what it means? All right. How many of you would say you use it on a regular basis? Okay. So my goal for today is to show you how to use TDD and TDD practices, specifically in SQL Server, whether that's standalone SQL or whether that's SQL as part of a larger application. So to realize that goal, first thing I would like to do is kind of define TD, tell you a little bit about what it means, give you an example, kind of to make sure we're all on the same page. Kind of one of the reasons I wanted to do this talk also was because different audiences. So if you're an application developer, maybe you've done a bit of TDD, but if you're a DBA, primarily a SQL developer, maybe you're not quite as familiar with that. And if you're an application developer, maybe you've never applied TDD to SQL. So kind of both those audiences, I'd like to kind of wanted to review a little bit about what TDD is, just to make sure everybody's up to speed on it. Second, I think a lot of us have learned about the practice of TDD, but maybe we don't know what the benefits are. And those are very important, so I'll talk about those as well. And then finally, I'm going to look at a specific example of using TDD within SQL. I'll look at a real-life production scenario that I was involved with where I used test-driven development to drive the development of a SQL feature. So from a technical background, how many of you would consider yourselves to be application developers? All right. How about DBAs or SQL developers? All right, cool. QA or testing? How about BAs or Scrum Masters? Okay, anybody have any roles I missed? Good, I got everybody. So that's a good mix. That's kind of what I was hoping for this topic. So it's called TDD because it's test-driven. We write the tests first before we write any code. With a kind of a traditional approach, you write your code first, get it to work, and then you write your tests after. to verify what's already been coded. So for me, there are 3 basic steps involved with TDD. That's to make the test, make it fail, and then finally make it work. So the first step in TDD is kind of, I think, the hardest barrier to get over when you're first getting used to the practice. It feels like you're not doing a whole lot to write a test first. When you get requirements or specifications for your application, the first thing you want to do is you want to make that feature happen. If you're writing a test for it, it really doesn't feel like you're doing much. So that's a kind of a difficulty you need to just train yourself to get past when doing it. So one important point about a test is that it needs to be easy. It needs to be simple. You don't want it to do too much. And I'll introduce my one visual aid I have here. So see if
that was easy.
Okay, somebody hear that? All right, that works. That will come into play a little bit later. So you want your test to be easy to create and also easy to execute. And the tests that we're talking about here are unit tests. So how would you guys describe a unit test? What, when we say unit test, what are some features of it that make it a unit test, maybe versus something else?
Don't integrate with the database.
Don't integrate with the database. Okay, good.
Test like one function.
Okay.
Instead of functionality.
Yep, test one functionality.
Dependencies are mocked out.
No limited dependencies. Somebody said it doesn't integrate with the database. Small and contained. All right, good. You guys kind of stole my thunder here for the next section. So to me, a unit test, first of all, should be fast. Ideally, you want to run your tests while you're working. Run those tests repeatedly to make sure to know when you're done, to know if something failed. And if you're going to do that, it's important that they be fast. If it's going to take 2 minutes to run your tests, you're not going to be running them very often. A test is also faster if it's isolated. As was mentioned, removing dependencies is part of that. If a particular method is interacting with other classes, other services, it's going to take longer to run that test. So you want to make sure that it's as isolated as possible. And also what's important about isolation is that if a test fails, you know immediately where to look. And then finally, a test should be repeatable. If you have any setup or teardown to do within your test, you want to make sure that's all part of your test itself. You don't want to have to set certain values, run your test, and then have to readjust those values. All of that should be part of your test, so it can be repeatable and run faster. So let's look at a quick concrete example. So we've got our easy button here. Let's say we want to create a computer simulation, a model easy button. So our first requirement is going to be to create an easy button with a click method that returns that was easy. So pretty simple definition. And let's go ahead and write a test for that. So we're going to call the test. You want to kind of give it a descriptive name. We're going to call it test easy button click. And we're going to use what's called the AAA pattern, arrange, act, and assert. We'll do the arrange section first. And in the arrange section of a test, you kind of create everything, set up everything that you need in order to execute the code under test. I'm using C# here, but this is kind of the same pattern you would use for any language that you're testing. So first I create an instance of my easy button. Then I create a variable called expected, because this is what I expect to come back from my code under test. That holds the value that we want to see. Then in my act section, I will actually execute that click method and store the output in a variable called actual. And then finally, we're going to assert. An assertion is just a verification that something is, that verifies that the executed code does what you expect. So in this case, we're asserting that the actual and expected values are equal. And it'll pass or it'll fail based on that comparison. And again, this is a pretty simple test. We're testing one object, we're testing one method, and one return value from that. So now that we've created our test, we do the second step, which is to make it fail. And this is an important part, and this is a part that I often skip, and I'm usually sorry that I do. So you want to run your test first, make sure it fails, because if you don't, maybe your test is passing by mistake, and then you won't know as you continue to code and run your test. You won't know when you're done. You won't know whether the code you're actually written does anything. So let's go back to our test. Is this test going to pass? What do you think? If we execute this, what's going to happen? It's going to fail? Any thoughts on exactly how it's going to fail? I'm sorry? Compiler. Yes. So, and why is that? Why was there a compiler failure? There's no easy button. So, which is good. This should fail because we don't have any easy button. If this passed, we would know something was very wrong. So we've completed the make a test step, the make it fail step, and now we need to do the make it work step. That's our next thing. And the trick is in TDD is you want to write as little code as possible. The idea is once your test passes, then you stop coding and you write another test. And the idea is the less code you write, the less code that you have to maintain, the less there is to go wrong. So next thing we'll do is we'll write the implementation for this test. And it's pretty easy. We have our class, our button class. We have our click method, and we return that was easy. And at this point, that's all we need to do. The test isn't asking us to do any more than that. And if we run it again, we have a passing test. Our test is just expecting that value to be returned. And then, again, the important part is once your test passes, you want to make sure that that you stop and you write another test. If you continue to write code after your test passes, you risk adding code that you essentially don't need. So now that we have a general idea of what TDD is, let's take a look at why we would want to use it. What are some of the benefits? And that's important because TDD is not a free process. As you can see, we had to do extra work to get a test in there. It would have been a lot faster and simpler to write the code for that. Having a test suite for all of your requirements is kind of like a second code base that you have to maintain. So it's important to understand what the benefit is of having all that extra work and extra code. So the first benefit of TDD is that it improves code quality. If you're constantly running your tests, if you have a test for every requirement, the more you check for correctness, the better your quality is going to be. You're going to catch defects sooner. You're going to catch them more often. You're just going to have higher quality code. It also can help you improve the design of your code. So if you think back to our easy button example, when we were writing our test, we had to think about how we wanted our code to be. We had to think about what our easy button API was going to be, and we had to write to that. So in more complex examples, writing tests first can help you really think about how your code should react as things get more complicated. It also can improve your testing discipline. So from experience, I know that writing tests after doesn't always work because you don't end up doing it. That's something that always gets cut. We say, well, we just need to get this to work, then we'll write our tests after. And that after really never comes. So obviously, if you're writing those first, you don't have to worry so much about whether you're going to have tests or not. You're going to have less areas of low code coverage. And then finally, TDD helps you with documentation. You can have written documentation for an application, and it will go out of date almost immediately, right? Because nobody wants to update that documentation. They want to change the application. They don't want to update documentation. But if you're constantly adding tests, updating tests, making sure all those pass, when you run a test suite, you can have a pretty good idea of what your application is doing and whether or not things are working based on actual code executed. Kind of my number one reason for using TDD is really just the confidence to make changes. So it frees me up to just make a bunch of changes, refactor code, and know that something's going to work even after, because I continue to run my tests. I'll know if everything is green, if tests are still passing. I know that the code I've written is good and I'm making good progress. So has anybody had the experience of working on an application where it has no tests and nobody wants to touch it and everybody's afraid of it? Yeah, okay. So yeah, I've been in that situation as well. I recall one project I worked on. There was one class that had about 50,000 lines of code in it. And so people would monitor the source control, and if anybody saw a change to that class, like sirens would go off, and people would start running around the building, asking, why did you make that change? Are you sure is it going to affect anything else? So having tests in that situation can really help you. You'll make a change somewhere, something will blow up. Managers will want to know, well, why didn't you test that first? And they say, well, we did. We tested it as much as we could. We put everybody's hands on keyboards. So TDD can really help you solve this type of problem. All right, so that brings us to kind of the how of TDD in SQL. And we kind of have to ask two questions about testing data in SQL. And the first is, how do we test our data, and also when do we test our data? So what are some of the ways that you guys approach data testing? Anybody want to throw out? Yeah.
Usually through integration tests.
Through integration tests? Okay. Yep. Integration and acceptance tests? Yes. Anybody else? All right. So kind of when you're writing an application that depends on a database, a lot of times you're going to mock out that database, right? That's something we talked about when talking about a unit test generally, because a database is an external dependency. It can slow down your unit tests. So that's, a good practice in application development. However, it's good for your application, but it's also bad for your data, because if you're mocking out that database, you're removing an entire section of your code base that's not getting tested. So what are some ways we can do that? One is we can use manual queries. I think we've probably all done this. You just write a query against some of your data, against some of your tables, to see what you get back. And that works to an extent, but as your requirements change, as your code changes, your database itself changes, you're going to have to update those queries, run those again. And you can sort of automate that. You can maybe run a batch script that's going to run SQL statements for you. But that's kind of a roll your own type of framework. Another method was mentioned is automation through integration tests. That's pretty good, but again, you're just testing your application. You're testing the data indirectly. It could be that you're not testing all paths behind your data. It could be you've got something wrong in your data layer, but it just happens to work in your application layer. So those are a couple of the kind of issues of how we normally test data. The other question is, when should we test our data? So when we're testing an application, we probably don't need to test every single thing. We don't need to test the features of a language itself. We don't need to test that a property of an object holds a value. We know that Java or C# is going to do that. And in the same way is for databases. We probably don't need to test that an insert statement works because that's a feature of the language. We don't need to test the underlying database. We probably also don't need to test things like our ORM Again, that's a framework. We want to test our application logic, not so much frameworks or languages or databases. What is useful to test, again, is our logic, is complex behavior and logic. Although stored procedures really aren't used as much as they used to be, they're not really used for CRUD anymore. We're using ORMs these days, but I think stored procedures are still a good choice if you're doing a lot of data manipulation and you want to be close to the database. So wouldn't it be nice if we had a kind of a unit test framework that allowed us to do what we can do in application development with our SQL development? And it just so happens that there is such a framework. And it is called tSQLt. It's a unit test framework for SQL Server. And it allows you to take a TDD approach to writing SQL, and it's installed entirely within SQL Server. It's open source. It's in GitHub. You can download it from the tSQL. There's a GitHub repository. You can also download it from their webpage at tSQLt.org. And a lot of frameworks clock in at high megs or gigs of space. But the tSQLt framework is about 84K, which is interesting. So you can pull that down pretty fast and get to using it. So what I'd like to do is walk through a real-world production feature that I used working on a project at Cardinal using this framework. But in the interest of client confidentiality, I've changed pretty much everything about this particular case study. I've changed the industry, the client, the product, and only really the core business unit remains. And that's been simplified a little bit just to make it easier to demonstrate. So I'd like to introduce you to our client. Here he is. Does anybody know this guy? Ron Swanson, that's right. So what's Ron best known for? Drink. Anything else? Being a government employee.
Do it yourself.
Yep, DIY kind of guy. Do you like bacon or you're wrong? All right, so he's best known for being the director of the Pawnee Rec Parks Department. He was director for about 6 years. And after he retired from a long and illustrious productive career as a civil servant, what's less well known is that he went and bought and operated his favorite store. Does anybody remember his favorite store? Food and Stuff, that's right. So Food and Stuff is located at 729 Glenmore Boulevard in Pawnee, Indiana. And Ron buys all his groceries there. He buys all his stuff there. And Ron's a practical guy, so he describes it as a discount food outlet equidistant from my home and my work. So, and according to him, Food and Stuff has a broad and diverse catalog of items. They've household supplies, garden supplies, industrial tubing, buckets of different sizes, fish tanks, shelving units, and lead-based paints. So, and it's not only products that they have, they also perform various services. They've got engine repair, they take passport photos, and they also do catering as well. So Ron's been doing pretty well for himself. His business has been strong. As part of his shop, he's got this point of sale system that he's been using. Yeah, so no one has ever accused Ron of being a slave to technology. He's not really the kind of guy who wants the latest and greatest, is he? So he's using the system to take customer orders. He's using it to track his inventory, manage his books, and all that stuff. So, but Ron has a few problems that he's experienced. First thing is that he has about 12 million new customers in his database over the last 6 months, and the entire city of Pawnee has only about 80,000 people. When he runs customer reports, he keeps seeing the same names over and over and over. His point-of-sale system also allows him to send promotional materials to his customers to remind them when there are sales or when Ron gets new items in, like almond butter or cattle prods. So, and he's been getting complaints that his customers are getting 4 or 5 copies of his newsletter, and he's having to spend a fortune on postage. So what is Ron's problem, do you think, specifically with his system or with his database?
His database has duplication of data. Customers are in the database multiple times.
That's right. Customers are in the database multiple times. He has duplicate data. So has anybody experienced a system like this? Yeah. Okay. So what are some reasons why we get duplicate data in a system? No rigor around data input, no validation. Yep.
When a customer makes a transaction at a point of sale, the system doesn't see if that data is already in the database. It just adds a new line.
Right. When a customer is ordering, the system doesn't check for a new customer to see if they're already in there. So Ron has asked all of us here and everywhere to solve his problem, and we are all known collectively as absent stuff. So you probably didn't realize you were joining a startup when you came to Stir Trek this morning, but that's what we're going to do. And he wants us to fix his duplicate data problem, and he's got 2 basic requirements for us. First of all, he doesn't want to have to check for duplicates up front. He doesn't want to do a search and then have to see if a customer's there. He likes his order process the way it is. If his screen changed at all, he'd probably have a heart attack. And he's worried that his customers are going to have a slow experience when they're going through an order process. And the second is that he wants to be able to clean up duplicates himself. He thinks, as profitable as it might be for all of us to come in every week and cleanse his database for him, or write a script for him to do it, he wants to pick out the customers himself and see what the duplicates are, because no one knows his customers like Ron does. So we have to build a solution that allows Ron to access the data, to find duplicates, and to merge those duplicates together. So the first part of our solution is going to be a UI component. So this is the actual screen that allows Ron to find those duplicates. The second part of the solution is the back-end database. That's where we're going to focus our effort today. So what we're going to do is we're going to write a stored procedure. It's going to take 2 customer records, and then it's going to merge them together into one. So the UI is going to find the customer. So let's say our example is we find Ron Swanson and Ronald Swanson, and those are the same person. And at the end of this process, we want to come out with Ron Swanson and combine those into one. It's a little more complicated because we also have to merge the order histories. So not only do we have to merge the customer, everything that either customer ordered needs to be under a single customer. So let's take a look at the data model. So this is an extremely simplified model. I wouldn't recommend this for a production system for anyone, but this seems to work for Ron. So we're going to go with this. So we've got our customer table, which contains first name, last name, and loyalty ID. We've got our order detail table, which has an ID and then also has the item name. And then we've got an order table, which just joins up a customer with that order detail. So when we're done, we're going to have a single customer with all the orders, and then the other customer is just going to be deleted from the system. So before we get started writing our procedure, we need to get our TDD framework set up. As I mentioned, the tSQLt framework is very small. It only has really 6 files. So it's got a couple text files to describe how to set it up. It's got the license and release notes. then it has a script called setCLR enabled. So part of what tSQLt does, it needs some compiled assemblies for. And you also, so for security measure, you need to enable those CLR assemblies on SQL Server. So this is something you're going to want to put on your development server, not on your production server. And then finally, we can execute that tSQLt class script. And what that does is it creates all the store procedures, functions, tables, whatever tSQLt needs to function. And it creates its own schema. So everything it creates under a tSQLt schema. That way it's separate from anything else, from your application code or your tests or whatever you've got. So that's pretty easy to set up. Once we've got that going, we can start writing our tests. And we're going to do two things. First is to create a test install script. So we're going to write a SQL script that includes all our tests and that we can install within our database. And then we are going to create a test run script. So first thing we'll do is we'll create that test install script. And the first thing I usually do is put a use statement at the top, because most of the time when I create objects in SQL, I forget to do that, and I forget to change the little thing up in SQL, and it goes in my master database. So I'm always creating objects and going, where'd they go? And they're in my master database, right? So I think my master database has a few items from just about every project that I've worked on. So I make sure that I specify that so I know it's going in the database it's supposed to go to. So to execute a tSQLt command, you type tSQLt and then a dot, and we're going to run our first command, which is new test class. And what this does is it creates, it's called a test class. Really what it does is it creates a new schema in SQL Server called FAS tests. And creating that space gives us, again, that separation. Our tests are in a separate space, namespace from tSQLt itself, and a separate namespace from our tests and our application code. One note about using this test class is that if there's an existing test class or schema with this name, it will delete it. So that's good if you are continually updating scripts and running them. So you want to make sure that you script everything out rather than working within the SQL interface itself. I recommend scripting everything and then just continually running those scripts to update your database. All right, so next thing we're going to do is create a procedure that will insert all the test data that we need for our tests. And we will insert our data for the customer table. So we're going to give a couple IDs. So Ronald is ID 1, Ron is ID 2. And in this case, Ron is the customer we want to keep, and Ronald is the duplicate that we're eventually going to want to get rid of. The loyalty ID tracks who gets what in terms of like discounts, that kind of thing, like a rewards number. And it's important that we have this because otherwise we would have no idea of knowing if something was a true duplicate or not. So it's very fortunate that we have a number like this in our database. We'll do the same thing for orders. So we'll give it 11 and 22 just to make it easy to match up. Again, at the end of this process, both of these orders are going to be under Ron's customer record. And we'll do the same thing for order details. And you can see Ron is ordering, let's see. Yeah, Ronald is ordering the 20-pack of steak, and Ron's got the 100-pack of bacon, so clearly this is a duplicate. This is clearly the same person. So from here, I'd like to talk a little bit about the concept of fakes or mocks. And this is important for the isolation that we talked about before. So let's say a particular method, a test includes a web service call, a database call, something else. We can create a mock for that, which I'll show you an example. So if you think about back to the easy button test that we had in the easy button implementation, let's say instead of having a hard-coded string returned, we put a service call in here instead. So I'm kind of using some pseudocode here just to make it a little clearer. This won't compile and run. So when you call click, it's going to go out to this message service and return whatever this service wants to give back. So we have a problem here with our test because now our test is testing not only the click method, it's also indirectly testing our service. That's going to make it longer. It's going to have a couple of potential points of failure. So what we can do instead is create a fake of that service call. So we're going to say we're going to pass in this service, and it's going to go ahead and return our hard-coded string. That way we know it's going to be fast, and it's going to work every time. So one of the concepts in tSQLt is creation of a fake table. So instead of testing an actual table, what the fake table command does is it creates a table with the same name, but it isolates it. It removes all data. It removes any constraints that are on it. So you can test that table in isolation. We can also create if you create a store procedure called setup in tSQLt, that gets automatically run before any test. So we can use that to leverage some setup work that we need to do before each test. So before each test, we're going to create these fake tables. We're going to insert our test data in those. So here's kind of what that looks like after we run our setup. We've got our customer table with the records for Ron and Ronald. We've got our order detail table with meat extravaganza that belongs to those guys. And then we've got an order table that simply links customer to the order details. And important to note that this only happens when the test is run within tSQLt. tSQLt does its work and does a rollback at the very end. And it's convenient because you can do whatever you want within those tests, and it'll return to original state. You don't have to do any teardown. You don't have to do any rollback yourself. So we're going to go ahead and create our first test here. In tSQLt, a test is a store procedure that starts with the word test and a space, and we can give it a descriptive name. So here we're going to say, given our merge of customers, then we're going to check if our customer table data is correct. So we'll start our arrange section. And so remember, when we start this test, we've run that setup. So these tables are going to be populated with our test data. So we can go ahead and set up what our values are going to be for the two records. And then a couple things that we can do for our expected first name. So we're going to need to, just like we did in our other test, we need to capture the data that we expect to see so that when we actually run it, we can compare it against to the expected values. So we could either, our expected Ron first name is going to be Ron, right? So we could either hard code that, or we could do a select from that table. That way it's a little more dynamic. We can change the IDs of the people if we want, and that'll drill down for each one. So we can do that. The same thing for all the fields that we've got for the first name, last name, and loyalty ID. So how do we compare what we expect to see versus what actually happens? And we can do that with a table compare. So, and to do that, we can create a table that mirrors our customer table within the FAS test schema. So, and then what we'll do is we'll insert our expected values into the table. So what we should expect to see at the end is one record with just Ron in it. So that's what our expected table looks like. At the end of this process, we want to make sure that what we actually see in that table is what we expect to see. So that's it for the arrange section. We'll go ahead and create this. Create the act where we execute the code under test, and that's going to be merge customer. And then we'll pass in who our duplicate is and the customer that we want to keep. And then our assert section contains tSQLt, assert equals table. So we are saying what we expect, what our table is expected to see, and what table we're comparing it to. So we're comparing expected to customer and making sure that those are identical. And we can include an optional fail message there as well. All right, so now that we've created our first test, we can create our test run script. And this is pretty simple. Again, we've got our use statement. And we can do a run all statement. We can do a run statement, which we can do a run all statement, which runs all tests in all schemas. We can do a run, which can run, and we can pass the schema name to it, so it'll run all tests in that particular schema. We can also do run with one particular test, and it'll run only that test. All right, so if we run this test, what's going to happen? What do you think is going to happen? Now we've made our test, now we need to do what? If we actually run this test that we just created, what's going to happen? Yeah, need to create the store procedure, right? So it's going to first thing it's going to give us is the actual SQL error, which it could not find our merge customer store procedure. So that's what we expect. So now that we've got a failure, we can go on. So for our code, let's go ahead and start actually writing our store procedure. For our code, what's the least amount of code we need to pass this? So at the end of this, we want to get rid of the Ronald record, and we want to keep the Ron record. What's some SQL that we could write? So here's the customer merge skeleton. What's some code we could write here? What's some SQL to make that table show what we want it to show? Could do that. We could do a count of how many times Ron appears in the table. And once we have that, what do we want to do with it? If we just want, we've got 2 customers in it, and we want 1 customer to remain. Delete the duplicate. So yeah, so we delete the customer where the customer ID equals a duplicate. Yes, best practice would be to copy it off into a separate table. Yeah, this is simplified for reasons. Yeah, so you would want to archive this or audit it, and that's what we did during our actual projects. We archived these, created an audit table. So let's run our test again, and tSQLt shows us that we now have a passing test. So let's write another test for our order table. This test is a little different. We want to keep all order history. So what should the bottom table look like after we run our merge customer store procedure? If we want all orders to belong to Ron.
The customer ID for order 11 should be 2.
Yep, customer ID for order 11 should be 2. So all orders there for customer 1 or 2 should belong to customer 2. So let's write a test for that. So again, we'll set up our expected table with our order ID and customer ID. So how should we fill the expected table here? If we expect it to look like the table at the bottom with 2s in the customer ID, how do we recreate that with our SQL statement against the data that we have? Any thoughts? Yeah, so this bottom table, this is what we're dealing with before our test, how can we create an expected test of this, or an expected table based on this data that we can compare against? Any thoughts?
Is there a way to set the customer ID into the table?
Yep, we could do that. So what we could do is we could select all records that belong to either Ronald or Ron, and we could insert Ron's ID for all of them. So that's kind of one way of getting all those records to point to Ron. So let's finish up with the act and the assert, and this is going to be the same as before. We've got our merge customer, our passing in duplicate and customer to keep. Then in our assert equals table, we're passing in expected, but we've changed this time. We're not comparing customer, we're comparing order. So we're going to run both of these tests to make sure that our code still works from before, and to make sure that our second test is, see what our second test does. So what do you expect to happen when we run this? Second test fails. Yes, that's correct. So our first test succeeds, and then second test does fail. So one interesting thing that we get when a assert compare table fails is that we get kind of this graphical readout of what the data looks like. And since this data only appears while the test is running, it doesn't appear after or during it or after, this can help us out a little bit. So the equal sign means that this record appears in both the expected and the actual table. The greater than sign means it's in the actual table, but not in the expected. And then the less than sign means that it's in the expected table, not the actual. So that can be good for helping you debug. So now we want to make, again, this bottom table have both IDs, both customer IDs pointing to Ron. So what's the least amount of code we need to accomplish this? What's some SQL we could write to do this? Update? Yep. So we're just going to update order and set the customer ID to customer to keep, where it equals either customer that we've got. All right, so let's run our tests again, and they both succeed. Now both are passing. Now because order detail is tied to order, we don't really need to do anything with that. So we don't need to write a test for order detail. So now that our tests are passing, let's write kind of a live integration test for this on the live table. So here's the script, and this is kind of what tSQLt does behind the scenes. So we start a transaction, we declare our IDs, we execute our insert data, we run our merge customer, and then we're going to go ahead and select from those so we can see what happens. And then we'll roll it all back so things are back to the way they were before. And we have an error. So our tests are passing, but our live is not passing. What's going on here? Foreign key constraint. Right. So you're deleting the customer before you delete the order, so you've got a orphan order hanging out there. So remember when I said when you create a fake table within tSQLt, it gives you a blank table and takes out all the constraints. We get this error because in our test, we did not have that constraint there. So what we can do is tSQLt has another feature where you can apply constraints after the fact. So if you want, you create a fake table, which takes away all the constraints, and you can selectively apply those constraints back to the table. In this case, we're going to add that order customer constraint to better replicate what we've got in our live environment. So if we add that and we run our tests again, we are getting the exact same error that we get in the live. So what's the easiest thing, what's the simplest thing we can do to get that test to pass here? Yeah, we can swap the two. We can update the order, and then that way there's no orphan order record, and we can delete the customer safely. So let's run our tests again. Now we're back to passing tests, and let's run our integration test again and see what happens. And we've got everything as we want. We've got one customer, we've got Ron, we've got both orders pointing to him, and he gets all the meat. So we've still got this. As we continue to work on this, if we're adding more to that store procedure, we now have a suite of tests that we can use to compare and make sure that anything we add doesn't break anything that was working before. So again, we can, just like TDD and application development, we can continue to use these tests. So congratulations, everybody. Thank you. We've solved Ron's problem. Ron is very happy, and he's decided to give everybody a $5 gift certificate to Food and Stuff. So definitely spend it all in one place. That's all I have. Any questions? Again, I thank you for being here. Do I have any questions on Slack or from here? Yeah, you don't have to do the fake table. You could just leave it as it is if you just want to use it. Yeah. I'm sorry. The question was, is there any way to keep all the constraints on? And the answer is you just don't have to use the fake table. The fake table command will kind of rename the existing table and put a duplicate in there. So if you just don't use that fake table, it will use what's there. So yeah, go to the question. You could. The question was, can you run those tests against your real data? Yeah, again, for integration tests, like the integration test I showed, I could have run that. I could have created a tSQLt test, run those against the actual stuff. The nice thing about tSQLt and using the fake tables is that you don't have to worry about what's in your tables. It doesn't matter. You can put the data you want in there, and it'll reset at the end. Other questions? Do we have any questions on Slack or anything? Okay. Well, thanks, everybody. Appreciate you being here.